Okay, today I'm gonna look at a cubic function. So I'm gonna attempt example number 7, which is discussion question number 7 from your notes. So discussion question number 7, we are given the following function: f of x is equals to x cubed minus 3x squared minus x and then plus 3. So the first question, they say we must show that x minus 3 is a factor. So we must show that x minus 3 a factor. So whenever we are showing that something is a factor, we take that equation, we equate it to 0, and then we solve for x. So if we equate x minus 3 to 0, and then we solve for x, we will get x is equals to 3. Then we take that value of x and then substitute it on the original function. So we'll have 3 cubed minus 3 squared minus 3 plus 3. So this will equate to 0. So the fact that it's equating to 0, it's a proof that it's actually it's a proof that x minus 3 is a factor. So if you look at under the notes factor theorem and remainder theorem, this is what it means. If you substitute the value of x that they say you must divide, or the one that they say you must check whether it's a factor or not, you substitute on the original function, you should get 0. And then if it's a 0, then you say it's a factor, and then if it's not a 0, then we say that it's a remainder theorem. So it means that expression is not a factor to that function. So the second question, number B, they say we must factorize f of x fully. What does it mean when they say we must factorize? It means we must come up with solutions to this, which is going to give us, in fact, three brackets. So I'm going to use what we call a synthetic division. Synthetic division, you take the coefficient of the original f of x, which in this case is 1 minus 3 minus 1 and then 3. This comes from is the coefficient from the original f of x. We have 1 here, we have negative 3, we have negative 1, and then we have a constant 3. You must bear in mind that this must always be 4 terms. In case our f of x is not 4 terms, maybe it's missing x squared, you will substitute it here as 0, and then it must be in that order: the coefficient of x cubed, x squared, x, and then the constant. Then, since we saw that when we substitute 3, we are getting a 0, we will use that on our synthetic division, the 3. And then the first thing that you do, you just drop the first value here, which is 1. Then you say 3 multiplied by 1, you get a 3. Then 3 minus 3, you get a 0. 3 multiplied by 0, you get a 0. Negative 1, 0, you get negative 1. And then 3 multiplied by negative 1, you get a negative 3. And then here you get 0. So let me just revise how we do this. You will take the coefficient of the original function, and then you take the value that when you substitute on the original function, it gives you a 0. Then the first thing you do, you drop the 1 here. Whatever first value is there, you drop it. Then you multiply this with that, you get the answer. You write it on the next one. Then you add this 2, you get a 0. You repeat, you multiply this with that, get a 0. Then you add this 2, negative 1. And then you repeat again, this multiply by that is negative 3. And then this 2 makes a 0. Then if you don't get a 0 here, something is wrong. So it means you must fix. You must go back and check. It's either maybe you used the wrong factor or you just miscalculated somewhere. So you must always get a 0 here. So remember, the aim is to factorize f of x fully. We can say our first factor is the one that we substituted to get a 0. I will say is x minus 3 and then now this part. We use the synthetic division to get this part actually. So here you will always have your x squared, your x, and your constant, and you can see that the x is actually 0. So I could just take the x squared minus the 1, and this part that we get from the synthetic division, it will always form a quadratic function, meaning that you need to factorize further. And then this is difference between 2 squared, so that will be x minus 1, x plus 1. Then we factorize our f of x fully. That is number B on 7. And then continuing with number C. Number C, they say, find f of prime x and hence the coordinates of any local maximum or minimum points. Okay, I'm gonna start with finding the f of prime x, which you are familiar with. We did it on the previous work. F of prime x, this will be 3x squared minus 6x minus 1. So the local minimum and local maximum is actually our turning points, and you must remember that the shape of our graph is given like that or like this. You can read on your notes what affects the shape of the graph. So the local and minimum is actually our turning point, which sometimes they call it stationary points. So whenever you're calculating for the turning point, you have to do f of prime x, then you let f of prime x is equal to 0, and then by solving this you will get the x coordinate of the turning point, and you will take those x coordinate, you substitute on the original function to get the y coordinate. So let's do that. And just to clarify, why are we doing f of prime x and then we let it equal to 0? Remember what I said about f of prime x. F of prime x, it's our gradient function. So it turns out that if we have to sketch a gradient that touches the turning points, that gradient will always be parallel to the x-axis, meaning that the gradient is in fact 0. As you can see, when I'm trying to plot a gradient on the turning point, it's actually a straight line which will be parallel to the x-axis, meaning that there's no slope. So the gradient is in fact 0. That's why we are taking the gradient function, which is 3x squared minus 6x minus 1 is equal to 0. How do we solve this? You take the first value, multiply it with the last one, and then we get a 3 here, and then we decompose 3. When we decompose 3, we realize that in fact the only product of 3 is 3 times 1. So it means we need to use quadratic, because we can see that there's no way you can decompose this into the middle value. So let's continue with that and then use quadratic equation. So x will be equal to negative b plus minus b squared minus 4 ac all over 2a, and that will be negative 6 plus minus negative 6 squared minus 4 ac negative 1 all over 2a. 6 plus or minus 36 plus 12 all over 6. So I'm just gonna use a calculator quickly. 6 plus 36 plus 12 divided by 6, we are getting x is equal to 3 plus 2, 3 all over 3, or x is equals to 3 minus 2 3 all over 3. So what are these x values? These are the x coordinate of the turning point, which sometimes they call it stationary points. Where does the stationary come from? The stationary means more like constant, so not moving, 0. So we know that the gradient is stationary at the turning point. So those are our x values. Remember, on functions, when we have the x values of the x coordinate and then we want the y coordinate, what do? We'll have to take this, we substitute it back to the original. So this is what I will do next.